Good afternoon, guys. I realize that I've been reading a lot of fiction books. I love fiction. I love reading Piggy and Gerald's, Froggies, those kinds of books. Those are my favorite. Fiction's probably my favorite genre. But I realize I need to get some more nonfiction texts, you guys, because you know I love my fiction. So today I picked a book about magnets, and what's really cool is it's got a little activity you can do if you have these things in your house. And I'm going to try it out later if I can find some magnets. And I'm going to look on my fridge too because I might find some. But this one's called Science Starters Magnetism by Carolyn Bernhardt. And what's cool about this is you get to really see the different things of a nonfiction text in this book, like the table of contents right here. You guys know that's in the front. It tells us which headings are on which page. And we're going to start on page 4, where it's called Magnificent Magnets. Magnificent Magnets. I make sure I got to read the heading at the top. Snap! You hang your art project on the refrigerator with a magnet. Ooh, I see a bold word right here, magnet. I think that might be in our glossary in the back. Then you look inside for a snack. When you close the refrigerator door, magnets seal it shut. The doorbell rings. Your friend is here to visit. All of these everyday things use magnetism. There's another heading. What is magnetism? Magnetism is a force that pushes or pulls objects. It creates an unseen field around a magnet. Magnetism moves magnetic objects in a field. Now, I like this because it's got a picture up top, a photograph of a magnet, and you can see the little magnet shavings around it. And there's the magnetic field around the magnets. Most metals, including steel and iron, are magnetic. Wood and cotton are some non-magnetic objects. When I see that word non in front of the word magnetic, non means not. So I know that wood and cotton are not magnetic. Magnets can be very strong. The strength of a magnet is measured by pull force. Now, I know on the other page, I didn't point out, when I point on this page too, pull force is in bold, and that word is also going to be in our glossary. If you're not sure what that word means, you can go back to the glossary and figure out what it is. This is how hard a magnet must be pulled before it moves away from a steel sheet. So the picture, the photograph on page 9 is showing how hard the magnet has to pull before the steel sheet right there can be pulled up. All magnets have a north and south pole. When two opposite, my hands are opposite of each other. When two opposite poles face one another, they pull together. This is called attraction. Similar poles push apart. This is called repulsion. It means to push apart. Some trains called maglev use repulsion to move. So up top in our photograph, there's a label, the maglev train. There's the train, and it uses repulsion, okay? It pushes it apart to make it move. So the magnets push apart to cause it to travel. Types of magnets. There are 3 main types of magnets. Permanent magnets always have a magnetic field. These occur in nature, like the mineral lodestone. So on this page, there's a photograph of the lodestone, and it's got a label pointing to a lodestone. So you might have actually seen some lodestone before. Temporary magnets can become magnets only within a magnetic field. These include paper clips and nails. So paper clips and nails can become magnetic only when they're in a magnetic field. So right here, when they're in the presence of a magnet, they can become magnetic. Electromagnets are created through an electric current. A conductor, not a train conductor, different kind of conductor. A conductor is wrapped around a magnetic object. The object is magnetized when electricity flows through the conductor. Now down here, you can see there's the magnetic object. There's the label pointing to the conductor. That's what a conductor looks like. It's wrapped around it. And the electromagnet cores are on the bottom. These magnets can be turned on and off. That's really cool. So you can see they can turn this to where they can stick, they can attract, or they can turn it off and they'll all fall to the ground. Earth as a magnet. Did you know Earth is a big, weak magnet? Now I know weak means not strong. This means it has magnetic north and south poles. They are located close to the poles that we see on the map. So at the top, you see a little diagram, magnetic poles. There's the magnetic north pole at the top. The magnetic field is around the Earth, and then the magnetic south pole is on the bottom. Magnetism in our lives. Magnetism is all around us. We cannot see it, but we can see and feel how things move. But we can see and feel how it moves things. For example, compass needles are attracted to the Earth's north pole. They always point north. On page 18, you can see there's magnetism at work in medical equipment. So he's using magnets to help him. And then on page 19, you can see in the photograph that the compass needles are attracted to the north pole of the magnet. So it always points north. Many everyday things use magnetism to work. Doorbells are electromagnets that turn on when you press the button. I didn't know that. I learned something new. Magnets even store information in computers. What? I didn't know either. Magnets are everywhere. So here's the little experiment that I was talking about on page 21 called magnetic fields. You can see how a magnetic field works by making a paper clip float. What you will need: a paper clip, string, a rock or a small weight, a paper cup, and a strong magnet. You might find a strong magnet on your refrigerator. Those are strong magnets sometimes. Step 1, you tie one end of one piece of string to one end of the paper clip. So you see on the picture. Step 2, tie the other end to the rock or the weight. Step 3, place your magnet in the paper cup. Step 4, hold your cup with the magnet over the paper clip to pick it up. How high can you lift it before it falls? Ooh, I'd love to see if you try this out. Let me know. Maybe send me a picture or something. Now, I told you guys, and we know because we've studied a lot of nonfiction text, those bold words, those dark words that were in our book or in our glossary. So if I didn't know the meaning of some of those words, I could come back to my glossary and find out the meaning. So attraction is a force that pulls something towards something else. Conductor, remember we said it wasn't a train conductor. It's a material that electricity can flow through. So if I wasn't sure, I could go back and find that word. Remember we saw the thing that was wrapped around the magnet? That was the conductor. Electric current, a movement of charged particles. Electric currents make electric objects like lamps work. Field, a region or space in which an effect or force exists. Force, a natural power or effect that can change the speed or direction of something. Magnet, an object surrounded by a magnetic field. Magnets attract iron and other metals. Mineral, a substance that is naturally formed under the ground. Pole, either one of the two ends of a magnet. Pole force, the measurement of magnet strength. Repulsion, a force that pushes something away from something else. On the other page, on page 23, it has to learn more. So if you were able to elaborate, which I'm pretty sure they're closed right now, but when it opens back up, we can look up and see if we can find some more books about magnets. And then it's got some websites to find out more about magnets. And an index is also a part of a nonfiction text, which we've also talked about. It lists some vocab words. Now, these words might not all be in bold. Some of them might be. But if you were interested in a certain topic, like if I wanted to look up lodestone, I'm going to come over to my index, and it's in alphabetical order, and I'm going to find the L's. There's the word lodestone over here, and it's on page 12. So all I would have to do is go back to page 12, and I can find out more about lodestone. So the index is a huge part of a nonfiction text. It really helps us find things if we don't want to read the whole text. If we're looking for a little piece of it that we want to find more about, you can go in the index and find your page. All right, almost done. I'm going to click Finish Book. All right, so I know I told you guys I try to get Maggie on again, But we are enjoying this beautiful weather. I hope you guys are too. We just played with the frisbee outside for a lot. So she's really, really tired. She's taking a nap right now. So I hope you guys go enjoy this beautiful day. Do something outside in your yards, maybe, if you can. I'm going to go on a walk in a little bit with her once she takes her nap. So I hope you guys enjoyed the book about magnets. And if you find any more information or want to research more, I sent you guys a link to Pebble Go. I know they have stuff about magnets too. If you just want to comment something about it, just email me back. I miss you guys. See you later. Bye.